Good morning, mathematicians. I said we'd talk about the Yoneda lemma today. So I guess that's what we'll do. On this Thanksgiving Day.
Good morning, mathematicians.
I will thank you for giving me views and subscribing. And yeah, let's talk about the Yoneda lemma. Hello, Arad. Hello, Lockheed. Oh, you were second. You thought you were first, but you were second. Very close, though. An extremely close second. Perhaps the closest second that has ever been second. Let's go over to Leinster, my favorite source for... You already got a lemma? That doesn't mean that you don't need a lemma. And you need a lemma. Let me tell you, Boris, if there's one thing you need. You don't want your silly blog to dominate all the office hours. Is that true? Is that really true? Is it really, truly, truly true that you don't want your blog to dominate the office hours? But yesterday you got so excited you couldn't help yourself from writing another post about the Yoneda lemma. Well, hello, Katoli. Welcome. Well, now I've got Arad's blog. Not only is it bookmarked, but now Google knows that I go here, so I can just start typing Arad and it will bring me. Let's see what Arad has to say on the matter. Every once in a while, you find yourself thinking about Yoneda in a slightly new way from what you knew before. And in this post, you collect some beautiful perspectives. Probing spaces. That's how I think about it. Generalized spaces. Yes, right. Yeah. Function extensionality. This is, you guys were discussing this in chat a little bit yesterday. I feel like I'm leaning over a lot. I should be sitting up and moving my mic. Spaceship time. Probing spaces, generalized spaces, and one bonus perspective. Wow. And it came out a bit longer than expected. Oh, how long is this? This is... Yeah, well, I don't know if we'll read the whole thing today. Maybe. Or maybe we'll, skim the highlights. Gotta listen to Yoneda lemma yap. Yes, you do. Well, explaining someone what co-contravariant in tensors is on Discord. Nice. Lockheed, it sounds like you've got the perfect morning. I couldn't imagine a better way to spend a morning. Too many cables. My writing pad can't decide where it wants to be hooked up to. Okay, let's look. The perspective of probing. Yeah, I'll go over it more quickly, and those of you interested in getting Arad's wonderful opinion can go do a more detailed reading on your own. Oh, sorry. Lovely evening. Most lovely way to spend an evening, Lockheed. No, it was mine. It is always morning somewhere. True. For example, here. Boop, boop, boop. So we got our fundamental group, and it is a functor. But in fact, it's a very special functor because it is representable. Aha. In the homotopy category, right? Where S is some object and hom is some collections. It's not too hard to guess what it's represented by. Yeah, S1. Right. You maybe think I'm overcomplicating my explanation here, but rather than picturing loops inside S1, why not just think of S1 itself as a loop? This is true. This is intentional. The universal loop that you describe is the loop given by the identity function in there. Interesting. Seems like a very homotopy type theory almost perspective, thinking about the, inductively generated types or whatever. I can skip the basic examples. Yeah, okay. Yeah. Well, I don't know. Someone in here was asking about Lockheed also pointed out hotness going on. What was I gonna say? Yeah, there was someone here yesterday who was asking for help on the Yoneda lemma. So I wonder if they're in chat today. Because I want this to be helpful. But the point is, Yoneda, weakened form, Yoneda part 1. What does this say? It says we can send, not only can we send an object to a functor, not only can we embed. Let me write some of this out, actually. Arad probably said this already, but I skipped some of it. Not only. So a little preview for my video dropping at noon where I complain about Wildburger. Is that a good use of my time? I don't know, but I did it. And it's coming out. So if we have any category, we can embed our category into the category of pre-sheaves. Whoa, what was that? Into the category of pre-sheaves by sending an object to homs out of that object. But if this is a category, that means that we should also send morphisms, or if this is a functor, we should also be able to send morphisms here. Of course we can, in the obvious sense. But to what extent is this, faithful, I mean that in more than one sense, representation of our category? You have a friend quite interested in philosophy. You're going to make them watch the upcoming video. Yeah. I mean, the title's a little clickbaity. Well, I do talk about philosophy, but it's maybe not super philosophically rigorous. You thought me and Wildberger were ultra lovers? Well, I am partial to constructivism and finitism. But that is why I made this video, because I think he puts bad arguments forward, and he's doing those philosophies of math an injustice. You can think of uncountably, infinitely many things that you and Wildberger would disagree on. Yeah. Anywho, well, this tells us, boom, that actually, in this case, not only is it faithful in the sense that, the map on morphisms is injective. But actually, everything gets hit. So we have a bijection between these hom sets here. So that tells us that we can recover a version of our category inside this functor category, basically. Is it aleph 2 to the aleph null or aleph 1 or some other uncountable? It's somewhere in between. Continuum hypothesis denied. I think I've told you guys before that I've often thought about how I wish or thought about, like, oh, what would it look like to try and make a trading card game like Magic the Gathering, but for theorems. And I just had, because there's like in chess, there's like Queen's Gambit decline. So I could imagine there'd be like a standard opening called like Continuum Hypothesis declined. Why do you guys listen to me? I say the silliest things all the time. Maybe that's why. Maybe that is why. Okay. Anywho, this is the basics of Yoneda. We love to see it. Ooh, what's this example? Can be pushed even further. What's this example? We've seen the loop doubling on S1. Induces a similar operation on all loops in all spaces. Certainly you could define loop quadrupling and such. Define a negation. It smells like there's some algebraic structure to be found here. Hell yeah. Give me that stanky algebraic. There's a cookie clicker-esque game based on ordinals. Oh, really? Can you... What is it called? What is it called? There is an animation. S1 to the wedge of a point. Start at the contact point, go once around the first circle, and then go once around the second circle. This may be thought of as the universal composition of animations. The original cookie clicker is also based on ordinals. They just happen to be countable. Yeah. Hello, Paul Maurice. Hello. There are 3 different variants of the game, though, I see. I'm a little confused, though. I thought mu was just one animation. Are we talking about, are we composing it with itself? Well, anywho, it induces a map here. Wait, we're looking at the contravariant? We're looking at contravariant. It flips them. Wait, aren't these the covariant homs? Why did it get all flippy? Am I losing my mind? Note, there is also a co-Yoneda for contravariant. Oh, okay, that is a typo. Okay, good. I'm not losing my mind. I mean, I might be losing my mind anyways, but that's not the reason I'm losing my mind. Okay. Okay. S1 wedge S1, like the one in intersection homology. Okay, well, we have... okay. So this makes this into a co-group. Wait, isn't this just a group? Isn't this just a group? And that's precisely what makes... Oh, this is just a group. multiplication. So in fact, not only is this a group, but it's a group object. Oh, hell yeah. I love to see that. How do you bypass YouTube eating your links? Well, you can just tell us the name of it. I mean, I guess I could give you temporary permission. Arad is the only one I trust with permanent permission. Wait, do I make you a mod? I forget what I'm supposed to do. Yeah, let me make you a moderator. Can manage blocked words. Capabilities of standard moderator. I think this one. Wait, did I just give you too much power? Try posting it now. Oh, you said the game is called Ordinal Markup. Okay. Maybe we'll just use that. There we go. Ordinal Markup. Is this the game? Okay, how does it work? Increase ordinal h naught of 10 is 10. What does that mean? Three seconds of power used wisely by doing nothing. Yes, indeed, that was the wisest choice. Reach. It's a very slow game. Okay. I don't understand what I'm looking at though. What is h3 of 10? Maximal ordinal, but number does not increase. Let's do it. Maximal. Oh. Maximal. Huh? This button doesn't do anything. Okay. Reach 10 to 40 to markup. That didn't do anything either. What's going on here? Do we just click this button forever? What is this? Is this the right one? You haven't confirmed that was the right one. That doesn't. Okay, let me look at this. Maybe this makes more sense. Nope, this is like the same thing. New achievement unlocked. You got to start somewhere. Wow, okay. Well, this one won't let me click on anything. This game sucks. Oh, there's a guide? What? Huh? I have no idea what I'm looking at. Welcome to the unofficial guide of clicking a button. When you first load it, you're greeted by 3 buttons, a few tabs, and a massive ordinal at the top left of the screen. You start in the tab where 2 buttons are located, increase by 1, and maximize ordinal, but number does not increase. Okay. Ordinals are based on omega. Okay, I didn't see any omega. Did we just start at some crazy as h naught, some like crazy notation for an ordinal? That's super big. The fundamental rule in maximization in ordinals is that every number in the ordinal is larger. What? The Hardy hierarchy. Oh, okay. The Hardy hierarchy. Okay. shout out randomly again to my mom in case she's tuned in. She only tunes in for a few minutes, I think. So I have no idea if she's watching now. But integrals, coends. Yes. The maximized ordinal does the reverse of the limit ordinal case of the definition. Let's see. The Hardy hierarchy, the hierarchy of sets of numerical functions generated from an ordinal indexed family of functions called the Hardy functions. That's my favorite series, more than the Hardy Boys. Oh man, what a great name that would be for like group math competitions, to call your team the Hardy Boys. Oh my god, that would be so good. It is related to the fast growing hierarchy and slow growing hierarchy. Okay, I don't know what that is. But the idea of the definition comes from a 1904 paper where he exhibits this. Okay. Let mu be a large countable ordinal such that a fundamental sequence is assigned to every limit ordinal less than mu. The Hardy functions is then defined as follows. I see. Okay. H naught of n is n. H alpha 1 of n is h alpha of n plus 1. Probably got some transfinite induction stuff can probably be applied to this. And what is this last one? Alpha n denotes the nth element of the fundamental sequence assigned to the limit ordinal. Okay, if alpha is a limit ordinal, the end of the fundamental sequence. See, and now I'm in a whole rabbit hole. So what the hell's the fundamental sequence? I guess, yeah, this is just a cookie clicker with homework. Actually, you know what? I don't even know what cookie clicker means. Does that just mean you just click a button and do nothing else? Basically, the increase the ordinal button, it increases the ordinal in the subscript. And the maximize ordinal does the reverse of the equality in the limit ordinal case. Okay, it's making a little more sense. Right, so if it does the reverse. I see. Okay, let's, what was it called again? Ordinal markup? Okay, so let's go. Wait, why won't it start? Why won't it let me click anything? Let's go to the other one. No. Let's go to this one. This one worked for us. Okay. Yeah, so this is working. So let's see. Maximize ordinal. Okay, what? Let me think. What just happened there, though? We were at omega something something. Why is it omega squared? Why did we go to omega squared plus 1? This has something to do with the fundamental sequence, I guess. Let's see. Increase ordinal by 1. Let's go maximize ordinal. We can't do anything? Ah, okay, wait, something changed. Wait, how big does this have to get before I can do something? I don't really understand what's going on. Omega 2 represents omega times 2. Oh, I see. That makes sense. Yes, that's true. Isn't commutative. You know, I just made a video about like infinite cardinalities and ordinal arithmetic. And I forget my like basic properties of ordinals. Well, I guess I made it in the summer, but still I should know better. You need at least 10 in the finite to maximize. Okay. Right, I see, and that has something to do with this being 10 here, I think. Right. Okay. I'm starting to get it. Okay, now I like it more. Now I think it's less stupid. In set theory, a mathematical discipline, a fundamental sequence is a cofinal sequence. I remember reading about that a couple months ago, and I've forgotten already. All below a given limit ordinal, depending on author, may be restricted to omega sequences only. It's a sequence indexed by n such that for all n that is true and that. I see. Maybe that is enough of a detour. Maybe. Wow, are you getting bored by your own suggestion? Why does it look like homology of a number? Ooh. Maybe this is the next big thing in set theory. Define a cohomology theory of ordinal arithmetic. Yeah, how do we interpret that? I mean, to me, this looks like the shift operator in the derived category. So, and this, maybe, right? Sum of ordinals, maybe that's just a chain complex. Is the homology of a number in the room with us? It's in the room with me. I can feel it. Wow, this is gonna get clipped and cut up the next time I, review Vixra papers, and people are gonna say that I'm the one that's the crackpot. It's a holiday here, gang. Can't we have fun? Can't we just be silly little goofy guys and gals? Can we not? It's a huge rabbit hole. Every rabbit hole is worth it, Lockheed. Every rabbit hole is worth it, especially when you get sucked into one when you have other things to do, like postdoc applications. And then you just end up reading about something totally outside of your research field, and time goes by and you miss your application, and then you end up jobless under a bridge. But then you have the ability to contemplate infinity deeply. And you can't put a price on that. Indeed, S1 forms what's called a cogroup object in the homotopy category. It admits a co-multiplication map. Wait, am I crazy? Co-multiplication goes in the opposite direction, though, doesn't it? I thought co-multiplication goes from one thing into two. No? Am I crazy? Mu is also backwards. Okay. Co-inversion, co-unit. One thing Ordinals taught you is that no one knows how to make notation for handling big infinities. Well, I wouldn't say no. I think there is notation out there for big infinities. No, we just keep inventing new notations. 0 sharp. Scring Bungalow. Probably my favorite name in chat by far. It is true that no one has good notation for big infinities. 0 sharp isn't even that big, right? I think in the hierarchy of infinities. You should look at extended Veblen hierarchy. It has a weird notation. Extended Veblen hierarchy. Set theorists are really on just a whole different vibe here. Huh? This is not that crazy notation. Yeah, I don't see anything that crazy here. I've seen some crazy notation in my time. This is not that crazy. Perhaps its meaning is crazy. Perhaps there's some crazy stuff going on here. The co-multiplication is the pinch map that collapses 2 points on the x-axis of S1. Huh? 2 points of the x-axis? I see. That makes sense. Interesting. Any ordinal notation has the church clean ordinal as an upper bound. And 0 sharp is bigger than the church clean ordinal. Oh. Thus, no notation can incorporate 0 sharp? What does that mean? No notation for ordinals without gaps. I feel like to really understand that statement, I'm missing a lot of I'm missing some context here. Notation without gaps. What could that mean? Like some sort of notation that allows you to specify every ordinal. If I scroll down a bit more, wait, you mean in the Veblen function thing? There's probably a big leg. No, there's nothing weird here, bro. Nothing weird in my opinion. Okay, the ampersand's kind of weird. The ampersand is kind of weird. I'll give you that. The big difference is angles, is trochaic, and mathematicians is more ambiguous on stressed syllables? What? Huh? Mr. L, I have no idea what you're saying. Mr. L, I don't know what you're saying. I'm sorry. Oh, you mean the fandom page? Wait, what's the fandom page? The fandom page? You mean a Rod's page? What are you talking about? Any ord notation is computable. See, I also don't understand that sentence. What does it mean for notation to be computable? That's very weird. I don't know what it means for notation to be computable. But okay, I can accept that we want some sort of computable way of describing ordinals or something. And thus any notation that describes, let's say, uncountable ordinals must introduce gaps of description. Oh. I see. I think I get what you mean, because there's like computably many like ordinals or something, so we couldn't. I see. Okay, I think I get what you're saying. Oh, good morning, angels versus good morning, mathematicians. Oh, this is from yesterday's thing. Okay, angels. Oh, I see. Okay, sorry. I'm with you. Good morning. Yeah, I got to think about that. Maybe some 2-syllable mathematical term of endearment I could call all of you. Fandom page isn't that weird either. What's the fandom page? Transfinitely long matrix notation. Well, I guess weird is a relative concept. Weird is a relative concept. Okay, Veblen, I'll look it up. Veblen function fandom page. Is this what you mean? The matrix stuff? This is not that weird. Okay, that's a little weird. I will give you that. That is a little weird. Good morning, Hardy boys. Yeah. Hardies. Yeah. Good morning, my Hardies. Lil Hardy B. Oh man, that'd be my rap name. Lil apostrophe Hardy B. My last name starts with a B, so actually that would B for my last name, but also B for boys. Yeah. 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 So I'll most of that matrix stuff is not that weird to me, but I will give you this one expression here. I'll definitely give you that one. That's a freaky little thing right there. Similarly, any sphere is a cogroup object. And the functors they represent are precisely the higher homotopy groups. I guess in the same way, what was that guy with the string bungalow mentioned? I guess they're cogroups in the same way where you identify a smaller, because we had S1 and we identified two, like an S0 in there. So in the same way, if we had an S2, would we like pinch the equator? And that should be the map as well. That's interesting. Oh, and now we're going to get an explanation for why the higher groups are abelian. Let's apply Yoneda philosophy. We need to show that the cogroup is co-commutative. Without diving into precise definitions, this can be seen in the following drawing. Loops can't go through each other. S1 wrapped. S2 unwrapped. Loops can go around each other. Right. Right. Okay. Right. Okay, and this is another version of Ekman-Hilton and the little cubes E infinity operad. That is beyond me now. For a vast generalization of commutativity in terms of higher dimensional configuration spaces. Well, what do you know? Huh. Augustin Louis Cauchy won't do it. Cauchys? Oh, yeah. True. I could say my ALCs. Good morning, ALCs. Or just LCs, right? Louis Cauchy. My Cauchys. Good morning, Cauchys. That could work. Good morning, my Cauchys. Good morning, my operads. We got to try out different ones. You can actually exploit the Yoneda philosophy to represent even more complicated structures. Consider the following diagram, where we've got all of these things, our simplicial things, and yeah, face and degeneracy maps, co-simplicial object. Now here's a tease for curiosity. The specific cosimple object may reasonably be called an infinity-groupoid object in the category of topological spaces. The functor it represents sends every topological space to its underlying infinity-groupoid. Known as its simplicial nerve, also known as its singular complex. Various natural operations between those infinity-groupoids are predicted by the Yoneda lemma. As predicted by the Yoneda lemma, going to be represented as operations on the universal infinity-groupoid we've just seen. This is fairly abstract and frankly not useful in practice, which is why we love it, besides being fun to think about. You know you've really gone too abstract when you start a paragraph with the triangle has 3 sides and ends with infinity-groupoids. Hell yeah. Hell yeah. Okay, well, we might come back to this tomorrow. It's almost time to close up shop for the day here at the Math Emporium. But let's see what you guys are yapping about in chat before we go. Operads is NLab level dark magic. Yeah. You know nothing about them? That means they're infinitely complicated. And they'll be trivially trivial as soon as you know about them. You meant recursive ordinal notations, which were the notations in question in the context of fast-growing hierarchies. I see. And why there are computable is explained in the wiki page, but don't quote you on it. Interesting. Okay, well, gang, that's about it for today. Time to go apply for a postdoc scholarship thing that's due in, oh my god, it's due in 4 days. Oh my god, no, it's due in it's due in 4 days. But I did push my new preprint. Should be coming out maybe today, maybe tomorrow. It'll be up on archive, so finally get to share that with you all. We'll definitely be talking about it in these office hours soon. Do I recall Alvaro's video, should be an A in there, about congruent subgroups being evaluations of polynomial matrices? Yes! I recall that very well. It's in the back of my mind. I would love to spend some time thinking about it. Do I know of any texts on why that problem is important? I do not. You should definitely go comment on his video. I'm sure he will respond. Well, but actually, I mean, my guess is that there aren't any texts on why this is important. I'm guessing this is more just like something that has come up in his research that he was sharing, and or you know, it may be a known thing wider, but you know, at some point there's no, at some point there isn't any, you know, there's plenty of problems that there's no textbooks on because they just exist in the research literature, even if it's yeah. I mean, yeah, you could try commenting on that actual video. Maybe he'll answer that. I don't know. He's a professor, right? He's busy, so don't take it personally if you didn't get an email back. Where will I go? That is a good question. I don't know yet. For postdocs, yeah, I've applied some places. I'll tell you the places I've applied to. So I've got a couple applications coming up. One is in Melbourne. One is that one's been applied for, and the next one I have to complete is Sweden. So we will see. But I may also stay in Canada, so who knows. Unfortunately, in your field, you're supposed to understand what's going on in the end lab. Whoo, Spring Bungalow, you definitely gave yourself the hardest task. Whoa, what is this notation? What am I looking at here? Huh? What did I just look at? A squiggly hiragana character. Yo. For Yoneda? Crazy. So you're going to be internally scared of you once you finish, yeah. You're doing your master's in Sweden right now. Well, then maybe I will see you soon. Okay, with that, I'm leaving for real. Goodbye, everybody. Until tomorrow. QE.